And welcome to lesson 32.3. Today we are going to talk more about directions of a vector and resolving a vector into its component format. So we've talked a lot about our vectors and how they have magnitude and direction. And so far we've spent more of our time focusing on finding the magnitude. Today we're going to focus a little more on direction. So we've talked about the component form of this robotic arm piece would be 18.3, and then the overall magnitude, we would take the square root of a squared plus our b squared value, so we get about 18.248. Now, if we want to compute the direction of this, to find that direction, we are going to take tan inverse of our b over our a value, and again, make sure we are appropriately in the correct quadrant. So if we tan inverse b over a, we end up with about 9.46 degrees. That makes sense because this is in quadrant 1 in standard position. So then this would be our direction, our quadrant 1 value. This would be our direction. So we could do this for other vectors as well, again, using the component form of each. For instance, on this first one, we are going to the left 2, 4. Notice the scale on this graph. And we are going up 2, 4, 6, 8 on this graph. So what we can do is we can then find the magnitude of this by taking the square root of -4 squared plus 8 squared. So we have the square root of 80, which would break down to be 16 times 5, so 4 root 5, or about 8.9 if we're approximating. And then we would take tan inverse of that b value of a divided by our a value to get our directional value of, our theta value, I guess I should say, of -63.4. Now the thing is, -63.4 is not going to be representative of the direction of this vector, because think about this vector, it is pointing up towards quadrant 2, right? So we want to make sure we are finding an angle that's representative of quadrant 2 by taking 180 minus theta. Not 1880 minus theta, just 180 minus theta, which would be about 116.6. So those would be, again, appropriate forms. Any of those answers for magnitude. Now the second one, our component form, we are moving to the left 2, 4, 6. We are moving down 2, 4, 6. So -6 is our component form. So the magnitude then is going to be the square root of -6 squared plus -6 squared, aka the square root of 36 plus 36, which is 72. We end up with the perfect square of 36 times 2 going into this, so 6 root 2, or approximately 8.5, depending on how they're asking for it, would be your magnitude. Direction, okay, on this one, we want to be aware. Think about if we traced over this vector and we moved this to standard position, this thing is pointing towards quadrant 3. So when we take tan inverse of -6 over -6, what's going to end up happening is we end up getting a value that's not going to be in quadrant 3. We get this quadrant 1 value of 45 degrees. So again, you want to think about to be in quadrant 3, we would do 180 plus that theta value. So 225 would be our theta form there. We also want to be able then to resolve our vectors into its component form. So in order to do that, what you are going to do is you are going to take your magnitude and multiply it by the cosine of your direction, your magnitude, and multiply it by the sine of your directional value. So some of these are going to come from the unit circle. We see here 6 cosine 120, 6 sine 120 at 120 degrees. Your x comma y is at -1/2 square root of 3 over 2. So that's where they are plugging those in to find our exact values. And we can also use the calculator to approximate as well. So for some of these, for instance, the first one, to find our component form, we're going to take 8 times the cosine of 225. So 8 times negative root 2 over 2 is negative 4 root 2. After the 8 and the 2 simplify. B is going to be 8 times the sine of 225. So 8, again, sine at that value is negative root 2 over 2. So we get another negative 4 root 2, comma, negative 4 root 2 for that component form. We also see this presented to us with a picture. Our magnitude this time is 15. Our theta measure is 30. So we know that the cosine of 30 degrees is square root of 3 over 2. We know that the sine of 30 is only 1/2. And so you would write this as 15 root 3 over 2, 15 halves, or again, the decimal approximations. Some of these we have no choice but to use our calculators to approximate because negative 20 degrees is not a value from our unit circle. So regardless, we will have to use that. So 22 times the cosine of negative 20. Make sure you are in degrees mode, which we are good to go. And then 22 times the sine of negative 20 would be our B value. So 20.67, comma, negative 7.52. Now we also want to sometimes think about then what happens if we involve some addition and subtraction when it comes to these resolving. So we want to resolve and find the value of vector u plus vector v, and then from there find its magnitude and direction. So you're using your two resolved components and then adding those adding those b's together to find your overall new component form of your sum. So for this first one that they are giving us, they are telling us about vector s and vector t, and we want to find the magnitude and the direction of each of these corresponding vectors. So reminder with vector s, each time, its magnitude is 10, its directional angle is 125. So in order to resolve it, we would do 10 times the cosine of 125 and 10 times the sine of 125. The second vector t, it's going to have a magnitude of 15. Its angle measurement is negative 15 degrees. So we would do 15 times the cosine, 15 times the sine. And then both of these vectors have angles that are not from our unit circle. So we will definitely be using our calculator to approximate. So in order to get s minus t, we want to type in the calculator. Again, we are going to use, to find our component form, 10 times the cosine of 125 plus, make sure you close your parentheses, plus 15 times the cosine of negative 15 degrees. So here is component A. And then, we are subtracting for this first one. So we're going to subtract these through minus. So we get negative 20.22 for a vector A. And then we're going to use these exact same pieces, except to find B, you are just going to change this to a sine for both of these. So we can recall this. Here is our B component, 12.074. So first things first, again, is finding that component form of A and B. All right, next we want the magnitude then and the direction of these. So we're going to take the square root of negative 20.225 squared plus 12.074 squared. And our final answer then, I'm going to use some parentheses, select squared plus our B value squared gives us a magnitude of about 23.55. And then our theta value, again, if we think back on this, we need tan inverse of b over a. So tan inverse of our b component divided by our a component. And again, you could just type in the decimal approximation as well. This is giving us a more exact answer. We get negative 30.84. Okay, but we want to think about, if this is my component form, I went left and up, so that's really a quadrant 2 value. So really my theta is going to reside in quadrant 2. 180 minus the 30.84 will give me that correct answer of 149.16. So our magnitude and our direction. All right, we also might see this with some scalar multiplication to start. So in order to find the correct form on this one, we would want to do 2 times t and then minus s. So what's happening on this one is we are going to want to think about vector t. If we doubled this, what's going to end up happening is what 2 times t is you're doubling your magnitude to be 30 times the cosine of negative 15, and then 30 times the sine of negative 15. So when we're computing our component form for part C, we're going to take 2 times t, which again is 30, and then cosine of negative 15, and then subtract away from it that a component for s, which is 10 times the cosine of 125. So we get about 34.7 for component A. And then we're going to do the same exact thing except use a sign this time. And then we see the approximation on this one is about negative 15.956. So this is going to help us find then the magnitude and the direction, because we have this component form. Magnitude now is going to be the square root of that, 34.714 squared, and then plus the negative 15.956 quantity squared. We should be getting approximately for that 38.205. And then the direction is going to be tan inverse of our b value divided by our a value. Now in this case, you want to be careful. Theta is going to pop out to be a negative number. And what's happening when it comes to this is that makes sense, right? This is kind of a quadrant 4 value because you went to the right and down. So this could work. Or sometimes what happens is we like the between 0 and 360 version. So we would take 360 minus that. And that's also the exact same thing as saying 335.315. Okay, officially, it just depends on if they want you between 0 and 360. That could work, though. All right. Thanks, everyone, for watching. We will work more with these in class.